Okay, the cast rule. In order to understand the cast rule, the first thing you need to understand is the related acute angle. Okay? So, a related acute angle is the positive angle. It's an angle between 0 and 90. It's between the x-axis and the terminal side. So remember, it's between the terminal side of a given angle, and it's between the x-axis and the terminal side. Okay? So for example, 45 degrees is an acute angle. It's positive, it's between 0 and 90, it's acute. So it does not have a related acute angle. Because it's an acute angle, how can you have a related acute angle when it's an acute angle? So anyway, let's look at 5 pi by 6. Now, 5 pi by 6 is, let's draw it, and then we can calculate what the related acute angle is. So if we were to divide this up into 6 pieces and go 5 pi by 6, we get right there. That's 5 pi by 6. Now the thing is, why is related acute angle so important? It's because the trig ratios for 5 pi by 6 depend on this related acute angle, which is between the terminal arm and the x-axis. It depends on that little guy right there. So what, can you tell me what the related acute angle is? What's the angle between the terminal arm and the x-axis? What is it? But if the question is in radians, you have to give me the answer in radians. Perfect. Okay, 225 degrees. Let's see where that ends up. That's 180 plus 45. So there is 225. Now the angle is, the related acute angle is here. So to get the trig ratios for 225, we're actually looking at this right angle triangle that we can form right there. So can anyone care to tell me what the related acute angle here is? 45 degrees. Because 225 is 180 plus 45. This is 225, 180 plus 45 gives you 225. So the related acute angle is 45.
So is it the amount after 180 or the
Yeah. It's the amount after 180. It's always the angle between x-axis and the terminal arm. Excuse me, gentlemen. 5 pi by 3. Okay. This is 3 pi by 3, 4 pi by 3, 5 pi by 3. So now our related acute angle, this is 5 pi by 3. Now our related acute angle is here. Can anyone tell me what the related acute angle is? Pi over 3. Right? Because if a complete turn is 6 pi by 3, and this is pi by 3, then 6 pi by 3 minus 5 pi by 3 is pi by 3. This is pi by 3 here, right? To go from here to here is 5 pi by 3. And then to finish it off, this angle here to get back to the x-axis must be pi by 3. Okay, let's do an example so you can see what's happening. Notice this is a special angle triangle, right? 30 degrees. So don't forget, you have to memorize this. Opposite to 60, opposite to 30 is 1, opposite to 60 is root 3, and this is a 2, right? So let's do all the trig ratios for 30 degrees. This is 30 degrees. Can anyone tell me what is the sine of 30 degrees? Is equal to what? What is this cos of 30 degrees? 60. Okay, what's the cos of 30 degrees? Right? Do you agree if this is 30, there's a 1 here, there's a root 3 here, and r is 2? Notice that when x is, if this is the point, root 3 comma 1, right? X is positive here, y is positive here, hypotenuse is always positive, so this is, everything here is positive. All the trig ratios are positive. What's tan of 30 degrees? Yeah. What's cosecant of 30 degrees? Sorry? 2. Secant of 30 degrees. Yeah. And what's cotangent of 30 degrees? Cotangent? Well, you use this one. It's just root 3. Okay? So, notice that they are all positive here. Every trig ratio is positive. All. Now we're going to do 150. Do you agree that 150 is 30 shy of 180? So our related acute angle is 30, but this, our theta is 150. Do you agree that this would be, because it's left of the y-axis, this is negative root 3, this is above the x-axis, this would be 1 and this would be 2? Okay. So, do you agree that this triangle is equal to this triangle? So, what is sine of 150? Huh? What is sine of 150? It's going to equal sine of 30 degrees, and that is 1 over 2. We're relating these angles to the related acute angle. What is cos of 150? Minus root 3 over 2. So it's equal to negative cos of 30 degrees. It's negative root 3 over 2. Notice the magnitude of all these ratios will be the same, just the sign is different. That's what you need to realize. Tan of 150 is what? Exactly. But is it positive or negative? Okay. Notice the magnitude is the same, except this one's negative, this one's positive. That's what you need to realize. So, cosecant of cosecant of 150 degrees is equal to the reciprocal of this. So this is going to be equal to the cosecant of 30 degrees, and this is equal to 1/2. I am writing 2 over 1. I apologize. Sorry? Yes, thank you. It is just 2. You're absolutely right. Secant of 150 is equal to what? Negative 2 root 3 over 3, right? It's negative here, and cotangent of 150 is going to be negative, I'm sorry, there's not a lot of space here. I'm just going to do some whiting out a bit so we have some more space and it's not so hard to read. So cotangent, if I write it as a function of its related acute angle, will be negative cotan of 30 degrees, and that's negative root 3. Okay, so out of our trig ratios, which is the only one that was positive? Sine is positive, right? So far we have A, we have S, right? They're all positive in quadrant 1. Only sine in its reciprocal is positive in quadrant 2. Now let's move on to the next triangle with the next angle, which is 210 degrees. This is 210 degrees. So notice a related angle again. Here's the angle between the x-axis and the terminal arm is 30 degrees. So this is now going to be opposite the 30 is a negative 1 because it's below the x-axis. Hypotenuse is always positive. So sine of 210 degrees is equal to the negative, right? Because here it's going to be negative. Negative sine of 30 degrees, and that's going to equal minus 1/2. The magnitude will be the same, just the trig ratio, just the sign is different. Just so you know, CAST, the only positive one in this quadrant will be tan and its reciprocal. So, however, everything else will be negative. So I can just pick off my answers here. So cos of 210 degrees will be negative cos of 30 degrees, and that will be negative root 3 over 2. Do you see what's happening? They all have the same related acute angle, so their trig ratios are the same except for the sign. Tan of 210 degrees is equal to, well, tan is positive here, so it's going to equal the tan of 30 degrees, and that will be root 3 over 3. Cosecant of 210 degrees will be the negative cosecant of 30 degrees, and that is equal to negative 2. Secant of 210 degrees will be the negative secant of 30 degrees, and that will be negative 2 root 3 over 3. And cotan of 210 degrees will be the reciprocal of tan, which tan is tan and its reciprocal are positive here, so this will equal the cotan of 30 degrees, and that is equal to root 3. So do you see what's happening? The CAST rule tells us what is positive and what is negative. Sorry? Okay. Okay, so now let's do 330, which is over here. Now this is going to be negative 1, this is 2, this is positive, and well, the angle is 330, but the related acute angle is 30 degrees, right? So the only one that's positive here is cosine and its reciprocal. So sine of 210 degrees, of 330 degrees is equal to the negative sine of 30 degrees is equal to negative 1/2. Cos of 330 degrees will equal the cos of 30 degrees. Cosine is positive, and that's root 3 over 2. Tan of 330 degrees is equal to the negative tan of 30 degrees, and that is equal to negative root 3 over 3. Cosecant of 330 is equal to the negative cosecant of 30 degrees, and that is equal to negative 2. Secant of 330 degrees is equal to, well, cosine and its reciprocal are positive, so that equals the secant of 30 degrees, and that is equal to 2 root 3 over 3. And cotan of 330 degrees is equal to the negative cotangent of 30 degrees, and that is negative root 3. Better? So the whole idea being, the cast rule tells us what is positive, the rest is negative. If they have the same related acute angle, the magnitude of the ratios are the same, only the sign is different. Are we good? Any questions? I'm going to let you do the next one for 45 degrees. We're going to summarize everything. So, when we have a related acute angle, in this case our theta is equal to the related, is our acute angle, related acute angle. Do you agree this is y, this is r, this is x, and r squared equals x squared plus y squared, or r equals square root of x squared plus what? Just Pythagorean theorem. R is always positive. So you know sine of theta RAA is equal to y over r. Cos of theta RAA is equal to x over r. Jason over hypotenuse. Tan of theta RAA is equal to y over x. Cosecant of theta RAA is the reciprocal r over y. Secant theta RAA is equal to reciprocal of cos, which is r over x. And cotangent theta RAA is equal to x, the reciprocal of tan, which is x over y. So far, so good? All of them are positive here. All of them. Okay. Does this make sense so far? Now, any angle in this quadrant is 180 minus theta RAA, right? So if theta RAA is 20 degrees, then our theta is 180 minus 20 is 160. So here we have the terminal arm, right? This is theta RAA, but this is our theta. In this case, our theta is 180 minus theta RAA. So, my goodness, just slap them down. Sine of, we're going to use radian measures, so you get used, pi minus theta RAA, cos pi minus theta RAA, tan pi minus theta RAA, cosecant pi minus theta RA. This is tedious, but I'm trying to get through a point because you need to be able to express these angles in terms of their related acute angle. Now, these are going to equal sine of theta RAA, and we'll worry about the sign of it later, right? The positive or negative value. So we have y over r, x over r, y over x, the reciprocal r over y, r over x, and x over y. We just have to get the sign of it. You know by the CAST rule, CA, the only one that's positive here is sine and it's reciprocal. So the rest are negative. Negative, 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 negative. Do you see what I mean? That's easy. It doesn't get much simpler than that. Does it make sense? CAST. The only one positive here is tangent. In this quadrant. No, sine is positive in this quadrant. But in this quadrant it's tangent. CAST. The CAST rule. Yep. Well, that's the angle that lands in the second quadrant. It's pi minus the related acute. We're in radians. I'm using radians as opposed to 180. I just want to get you, do you agree that pi is equivalent to 180? So this is going to be theta RAA, pi minus theta RAA, pi plus theta RAA, 2 pi minus theta RAA. I'm just trying to get you used to radian measure too, okay? Huh? This is 180 minus theta RAA or pi minus theta RAA. Does that make sense? Okay, let's come down here. Down here, we're going to have, here's our theta RAA for this one, right? Sure. So this is going to be pi plus theta RAA. But the related acute angle is still the same as this related acute angle. So sine. Just slap them down, okay? We'll worry about the sine later. Is that my cell phone? Can you put it away, please? So which one would be positive and which one would be negative here? Huh? So tan is positive and its reciprocal is positive. The rest are negative. Oh, tan and its reciprocal are positive. Okay, now we're doing 2 pi minus theta RAA. So here y is negative, r is always positive. Oh, okay, I'm working on this angle now. 2 pi minus theta RAA. Oh, is that the issue? Okay, here it is. Here's 2 pi minus theta RAA. So here's 2 pi, 2 pi minus theta RAA. Right, it's 2 pi minus theta RAA to end up there. Is that better?
So that's
You want me to slow down?
what's the red triangle?
That one's pi plus theta RAA. So now we're doing 2 pi minus theta, right? 2 pi minus theta RAA. The black triangle is 180 minus theta RA. Okay, which one is positive in this one? And it's reciprocal secant, so these are negative. And we just get the same values. Excuse me, I don't want to say your name on the internet, but could you please stop? Thank you. Okay, so cos is positive. That one's positive. Cos is reciprocal is positive. The rest are negative. If you didn't get this, if you find you didn't had trouble following this, it is summarized on the next 2 pages of your CAT package. See, do you notice it's here? It's all here. But I wanted you to, it helps you if you write it out. If there's anything you didn't get, it is here. This is 360 minus theta RAA, or pi minus theta, 2 pi minus theta R. Let's do some examples. But you have it all here, right? This one. The purple one is this. Yeah. You're okay? Okay, guys, on your test, you will have questions written like this. They will say, write the following. It won't just write it like this. It'll say, write the following as a function of its related acute angle and evaluate. So we don't want just the answer. 1 mark for writing it as a function of its related acute angle, and 1 mark for the evaluation. Now, all you have to do, if a diagram helps you, do you agree 120 lands in this quadrant? This is the 180 minus theta RAA quadrant here, right? Anything that lands in quadrant 2 is 180 minus theta RAA. Do you agree that this is the same as sine of 180 degrees minus 60 degrees? 180 minus 60 equals 120. Now this is equal to the sine of the related acute angle. The question is, which one, is it positive or negative? Now you know this is a special angle. What is the sine of 60 degrees? Right? Opposite over hypotenuse. One mark here, one mark there.
Wait, how'd you get sine 60?
Opposite over hypotenuse. Yes? You have to memorize this. This is a special angle, triangle. Yeah. If you recall, we did special angles last week. It's these, you need to memorize this. Okay? The special angles. When it's a 60 degree, yes. If it's 45, it's another triangle. Okay. This is now 240. Just draw a diagram. 180 plus a bit ends you up here. Agreed? 240 will end up in this quadrant. So this is going to be, this quadrant is 180 degrees plus the related acute angle, right? It's 180 plus whatever the related acute angle is. So this is going to be cos of 180 plus 60 degrees. This will be cos of 60 degrees. Using the cast rule, will this cosine be positive or negative? It will be negative. And what is negative cos of 60 degrees? So the cosine of 240 is negative 1/2. Yes? Was that a question? Okay. You have a, it's good? Okay. Yes. Question. This one? You don't have to. If you can write this and this, I'm happy. Some of your teachers next year will require this.
Wait,
So,
so how do you know this might be like a really stupid question, but like how do you know it's plus 60?
well, 180 plus 60 equals 240
So you always just do 180 plus whatever it is.
to get to 240 when it's in this quadrant. If you need a more detailed drawing, if this is 240, you know this is 180, so this must be 60.
Which then how is that equaling negative cosine 60?
Well, we know that the only trig ratio that's positive here is t. Cast rule, C-A-S-T. So that we know it's negative, and you get the cosine of 60 from this special triangle.
Why isn't it 30?
Huh?
Okay, you know what? Sure, yeah.
Well, this is a 60-30 degree triangle. 60 degrees is in this triangle. So it's adjacent over hypotenuse, 1/2. We know it's in this quadrant, so we know it's negative. Okay, tan of 210. 210 ends up here. So this is tan of 180 degrees plus 30 degrees. By the cast rule, we know tangent is positive, so this will equal tan of 30 degrees. What's the tan of 30 degrees? One over root 3. Rationalize the denominator, root 3 over 3. Now, if the question is in radians, your answer has to be in radians. Anyone want to tell me what it's sine of what? Pi plus what? Okay, so this is the sine of pi over 4, but is it positive or negative? So pi over 4 is the 45-degree triangle. And that's going to be negative 1 over root 2, which is equal to negative root 2 over 2. You have to rationalize the denominator. Yes?
How in this case did you know it was like 1 and root 2?
You have to memorize those triangles.
It was in radians.
Oh, because I know pi over 4 is equal to 45 degrees. Once you get more exposure, it'll become a little easier. Okay, tell me, what is this? The cos of 2/3 pi will end up in quadrant 1, 2, 3, or 4. 2 pi by 3, what quadrant is it in? Well, pi by 3 is equal to how many degrees? 60, right? So 2 pi by 3 is 120. So where does it end up? 2. The only one that's positive is sine and its reciprocal. So this is going to be pi minus pi by 3, right? Pi minus pi by 3 is 2 pi by 3. So we know cosine is negative here. And what's cosine of 60 degrees? Huh? 60 is adjacent over hypotenuse, so it's going to be I'm not sure what part you need. You need the 60-30 degree triangle? This one? Cosine of pi by 3 is the same as cos of 60. That's 1 over 2. Okay, 11 pi by 6, where will that end up? The 4th quadrant. It will end up here. This is 11 pi by 6. What is my related acute angle? So this equals tan of 2 pi minus pi over 6. That's 11 pi. See, will tan be positive or negative? How many degrees is pi by 6? What's the tan of 30? Very good. You can always in your head convert, but you can go pi over 6 times 180 over pi equals 180 divided by 6 equals 30. I think at this stage of the game, I think this is the best way, or memorize pi over 6 is 30 degrees. Well, 4 pi by 6, 4 pi by 4 is 180 degrees plus a quarter pi. It's in this quadrant. Well, pi equals 180 degrees. And then 4 pi by 4 equals, because they divide out, right? Okay. I'm going to do example 6 and then we're going to stop. Because it's quite a bit, right? This is where you have to remember coterminal angles. In order to get a lower coterminal angle, what do I have to do? Subtract what? 360. So, because 150 and 510 are coterminal angles, they have the same tangent ratio. Now, 150 degrees will end up here in the second quadrant. Here. This is going to be tan of 180 minus 30. Only sign is positive here, so right away this will be negative tan of 30 degrees. What's tan of 30? So if it's an angle larger than 360, then just subtract 360, get the next lowest one to work with, find your related acute angle, and we'll end it there. I know that was a lot.